Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the visibility algorithm in computer graphics. Visibility algorithm. In computer graphics, visibility algorithm are crucial for determining which objects are parts of objects in a 3D scene are visible from the particular viewpoint. These algorithms helps the optimize the rendering by ensuring that only the visible objects are processed, thus saving computational resources. Third one, there are several visibility algorithms, each with its own strength and weakness. The painter's algorithm is one of the simplest visibility algorithm. Next point, it sorts all the objects in the scene based on their distance from the viewers and renders them from the back to front. Third one, this approach works well for scenes with non-overlapping objects but fails when the object intersects. Next one, it is computationally straightforward but suffers from the sorting problem where determining the correct order for an object can be expensive. Next one is painter's algorithm. We have some steps. First one, start the algorithm. Step 2, sort all the polygons by z value. Keep the largest value of the z first. Third step, scan converts the polygons in this order. Test is applied. Next, first point, does A is behind and non-overlapping B in the dimension of z as shown in the figure A. Second one, does A is behind the B in Z and no overlapping in X or Y as shown in the figure B. If A is behind the B in the Z and totally outside the B with respect to view the plan as shown in the figure C. If A is behind the B in a Z and B is totally inside the A with respect to the view plan. The success of the any test with the single overlapping polygon allows to be painted. And the success of the any test with the single overlapping polygon allows F2 to be painted. Here we have the diagrammatic representation. Z buffer, that is depth buffer. Here that is A images, and this is the B1 and the C followed by the D. And the last step is here. Next one, the Z buffer algorithm is widely used and efficient technique for handling visibility. It uses the buffer known as the Z buffer or depth buffer to store the depth value, that is distance from the viewer, for each pixel on the screen. During the rendering for each pixel, the Z buffer is checked to determine if the current object is closer than what has already been rendered at the pixel. Next point, if it is closer, the pixel color is updated and the new depth value is written to the Z buffer. Third point, the Z buffer algorithm works well for scenes with the complex geometry and overlapping object. However, it can be memory intensive for high resolution screens due to the need to store depth values and the pixels. The Z-buffer algorithm is widely used and efficient technique for the handling visibility. It uses the buffer known as the Z-buffer or the depth buffer to store the depth value, that is distance from the viewer, for each pixel on the screen. During the rendering for each pixel, the Z-buffer is checked to determine if the current object is closer than or what has already been rendered than pixel. If it is closer, the pixel color is updated and then the new depth value is written to the Z buffer. And depth buffer is also used to store the depth values for x, y positions as surfaces are processed. That is 0 greater than or equal to depth greater than or equal to 10 and then greater than or equal to 1. The frame buffer is used to store the intensity value of color value at each position x, y. And the z coordinates are usually normalized to the range 0, 1. The 0 value for the z coordinate indicates the back clipping pan and 1 value for the z coordinate indicates the front clipping pan. The algorithm First one is set the buffer values, and next depth buffer, then frame depth buffer x comma y comma is equal to 0, buffer x comma y is equal to background color. Next, followed by the step 2, process the each polygon one at a time. Next, advantages and disadvantages. It is easy to implement. It is reduce the speed problem if implemented in hardware. It processes one object at a time. The disadvantages is it requires a large memory. It is a time consuming process. Thank you.